Bismillahirrahmanirrahim. Assalamualaikum and good afternoon. Today is Friday and we should have a very short session, maybe about only half an hour. So I'm not going to present a lot of things. I'm going to cover the new topic, which is on the Boolean algebra. And we have 59 slides actually, but today I'm going to cover only about 11, right? And after that, next week, we will continue. And also, most probably that we are going to start thinking about the first test, right? So I'm going to discuss with the Dr. Azizi. Let's see when we are going to do the first test, most probably that next week or week after, or maybe after Raya. It depends. So I'm not going to spoil your Raya. So most probably the after Raya lah, right? Everybody hear me?
Yes, sir.
So now I'm going to put the slides on slideshow, and now I'm going to share the slideshow. Okay.
Hi, sir.
Everybody see this lecture number 8 for the digital fundamentals. This is actually this lecture 8 will cover 2 chapters, chapter 4 and 5 from Floyd's digital fundamental textbook. So there are 3 main topics that we are going to cover: Boolean algebra, logic simplification, and Kanu map or K map. Okay. For short, we call it K map. Long is a Kanu map. Kanu is a person's name, if I'm not mistaken. Okay. Okay. This is the law of Boolean algebra. So before we can do this simplification of the logic function, we need to know a bit of the law of the Boolean algebra. The first one is the commutative law. Commutative law is basically for addition, when A plus B is equal to B plus A, or A at B is equal to B at A. So when you have the OR function, when you have the OR function here, that you have A, you have 2 inputs, A or B, therefore the result is A or B, or is also equal to, let's say, if put the B or A, then you get B or A. So A or B is equal to B or A. So the position of the 2 inputs can be interchangeable, right? Okay. And for multiplication, you have A, B is equal to B, A. So A and B is equal to AB, or B and A is BA. So the result is the same. So AB and BA are interchangeable. So these are the commutative law. So the Boolean algebra complies to the commutative law. Okay? Any questions so far? Simple.
Boleh, sir,
Another
boleh.
law.
No, sir. No, sir.
No question,
No question, sir.
Okay. The second law is associative law. For addition, let's say that you have 3 inputs, A, B, and C. So A or B or C, basically that you can do the B or C first, or you can do A or B first. So these are actually the same, is interchangeable, right? So this is called associative law. So in terms of the gates, logic gates function, let's say you have 3. So in this case, you do the B and C first. You do the B and C first. So B or C, then you OR with an A. So you get A or B or C. Okay, it is actually the same result as you do the A B. You OR the A and B first. Then after that, you OR with a C. So A or B in bracket or C. So it's still the same, right? Associative law for multiplication. So you have A, B, and C. So you can do, instead of B and C, you AND first. You AND B and C, so you get B, C. Then you AND with an A. So you get A and bracket B, C, close bracket. Or you can AND the A and B first, then you get A, B. Then the next step, you OR with a C. So A and B in the bracket, then you AND with a C. So this is associative law. Clear?
Clear, sir.
Okay. Next one is distributive law. This one also simple, just simple mathematics, and it also applies to Boolean algebra into the logic operation. So let's say you have 3 inputs, A, B, and C. So A or with a B or A and with a B or C, so it's actually equal to A and B or with A and C. So in terms of the logic gates, what you do is actually you do the one in the bracket first. So in the parentheses first. So B or with a C, so it becomes B or C. Then you end with an A to becomes X. So X is equal to A and B or C. Right? So this is really the same as if you do A and B, and at the same time you end A and C, then you OR the both output from these 2 gates. So therefore, X is equal to A and B or A and C. So this is really is the same. If you look at the implementation, so the first one is actually you save number of gates. So because these gates, each gates actually is built using the amplifiers or using the transistor. So the more number of gates, the more number of amplifiers that you use. And in terms of the space on the IC, the more space that you use. So in terms of this implementation, this 3 gates implementation requires more gates, more transistors or more amplifiers compared to the 2 gates implementation, right? So in terms of power consumption also, these 3 gates normally will consume more power compared to the 2 gates implementation. Okay. These are some basic rules of Boolean algebra, right? The first rule. So we have all 12 rules altogether. So the first rule is that A or 0 is equal to A. That one is simple. A or 1 is 1. A and 0 is 0. A and 1 is A. A or with an A is A. A or with A bar is 1. So number 6, do you need clarification on the number 6? A or A bar equal to 1. Can you imagine that one? If A is 1, for example, if you take A is 1, because actually that A can be 0 or 1. So let's say A is 0. You OR with A bar. What is A bar? If A is 0, what is A bar?
Oh,
A
1.
bar is 1, right?
Yes, sir.
So 0 OR with a 1, so it becomes 1. So if A is 1, OR with anything becomes 1, right? This. So basically that A OR with A bar is equal to 1 is actually you are using this, and this. These two. Okay. So it's equal to 1. Because if A is 1, therefore A bar is 0. So 1 OR with a 0 is 1. If A is 0, A bar is 1. So 0 OR with a 1 is equal to 1. So that is the rule number 6. Rule number 7. A and A is A. So if it's A is 0, and with a 0 becomes a 0. If A is 1, and with a 1 is equal to 1. A and A bar is equal to 0. Let's say A is 0, then A bar is 1. So anything n with a 0 is 0. If A is 1, A bar is 0. So anything n with a 0 is 0. So basically that number 8 actually using this rule number 3. Number 9, A double bar is equal to A. Let's say A is 0, bar becomes 1. 1 bar is becomes 0. So basically double bar is actually you get back the original value if you have double bar. What about triple bar? Let's say A triple bar is equal
0.
to
Equal to A bar.
A bar, bukan 0, A bar. If A triple bar, you end up with a bar. So anything which is which odd number of bars, you have bar. If it's even number of bar, you get
A.
no bar. Okay. Number 10. A or with A and B is equal to A. How do you do that? You use the which law? You use which law? This, something like this. You use distributive law. Here. A or A and B is equal to, because you can take out the A, right? So this end up with a 1 plus 1 or with a B. So A, this is actually this part, you can write as A.
One plus B equals to 1. Oh, jawapan A. Okay.
So A or with a B. So A, 1 or with a B is 1. This, you use this. This is actually here. So 1 or with A, 1 and with the A is A. So this becomes A. So basically that you use these two. Okay. Right? To come up with this rule. Okay. What about number 11? A or AB is also equal to A or B. How? Which rule that you use? Hmm. Which rule that you use?
Silakan. Eh,
Which
Addition.
rule?
5.
Huh?
5, sir.
5.
5 ke?
Or 6.
Okay. This one. A plus
7, sir.
AB is equal to, you use number 7, right? A plus A B, right? So then to take out A, then you get A so then after that, which one? You take which one?
2 and 4 semula.
Which one?
2.
10,
A
sir.
and B. A or B. So A, which one?
2 and 4.
2 and 4 ke? A and B, and this is A, which one? This one or this one? That you end up with A and B, A or B.
11 lah, sir.
Hmm?
11.
Ni, we are trying to find this. Why this one is can be dropped? That you end up with A or B. That you end up with A or B. So first, basically that you use this number 7. This, so that you can use the distributive. Right? So A, then you get A or B. Okay. So which one? Which one? If A is 0, then if A is 0, then is 0, right?
3, sir.
If A is 1, then is A or B. If A is 1, it's 1. If A is 0, it's 0. So which one?
3, sir.
3 and
This
4,
one.
sir.
3 and 4.
2, 3, 4.
This one, you try to think how. it becomes A or B. How to move from here to here?
2, 3, 4.
Basically that you will use this some of these rules, the basic rules. Number 12. Number 12. You use a distributive. So this one is basically A or A and A, then A and C, then B and A or B and C. So then this A, then you get A or C or B, right? Or B, C. So this is A. So this becomes A or B, C. How to move here to here? Try to think.
Apa ni?
Try to work
Number
it out.
6. Number 6.
1.
Number 6.
Number 6. Why
One.
number 6? No, it's not.
Mana ada A bar?
1.
Hmm.
1.
Number 4, sir. Rule number 4.
Rule number 4.
Yes, sir.
Are you sure this is 1?
Number 7.
Hmm.
Rule number 7.
Think about it.
Then
You
rule
think
number
about it.
5.
You think about it. I leave it for you to think.
Alright, sir.
Right, sir.
And you submit this as the
Exercise.
as exercise.
Alright.
Number
I don't know.
11 and 12, sir.
Alright, sir.
11 and 12. How basically that you move from here to here using which rule? So you have to work it out using all these the previous 10 rule. 11 to do 11 you use the previous 10 rule. For number 12 you use the previous 11 rule that you have. You try to work it out on your own. Okay. Next, De Morgan's rule. This is the De Morgan's first theorem. The complement of a product of variables is equal to the sum of the complemented variables. So A, B bar, so basically what you do is that A and B, then you not bar is actually equal to A bar or B bar. Right? So this is the first De Morgan's rule. So this is the first rule that you need to remember. So basically that this is a NAND. This is this NAND, which is A and B, then you not. So becomes AB bar. So this is a NAND, which is actually equivalent to negative OR, where you take A, you not, you take B, you not, then you OR it. So it becomes A bar or B bar. Okay, this is the De Morgan's first rule. So this is the truth tables. Let's say this one, 0, 0, 0, and 0 becomes 0. 0 not, then becomes 1 here. Okay. 0, 1, 0 and 1 is 0, not, then becomes 1. 1, 0 becomes 1. 1, 1 becomes 1, you not becomes 0. So that is the AB bar. For this one, 0, you not become 1, 0, you not become 1. So 1 or 1 is 1. So see,
1 or 1, yeah.
get this 1. Okay. Then 0 not becomes 1. 1, you not becomes 0. 1 or 0 becomes 1. Get this. 1. 1 you not is 0. 0 you not is 1. So 0 or 1 is 1. 1, 1. 1 not becomes 0. 1 not becomes 0. So 0 or 0 becomes 0. So basically that from the truth table, you prove that the NaN is equivalent to negative or. So that is actually the truth table for the De Morgan's first theorem. So AB bar is equal to A bar or B bar. So you have to remember this first theorem because this is important when you want to do the logic simplification. Second, De Morgan's theorem is the complement of a sum. The complement of a sum of variables is equal to the product of complemented variables. So A or B bar, so sum first, then you take the complement, is equal to, you take the complement of A and you end with the complement of B. So A or B bar is equal to A bar and B bar. So this one is actually this. And this one is this. Okay. So you can go through. So this is the truth table. You can do as what I've shown just now. So you can do it on your own to prove that, yes, both nor is actually equivalent to negative n. Okay. Example. Apply De Morgan's theorem to the expression W, X, Y, Z bar and W or X or Y or Z bar. So using the De Morgan's theorem, remember that basically the product, the complemented of the product is equal to the sum of the complemented variables. So W, X, Y, Z bar is equal to W bar or X bar or Y bar or Z bar. For the next one, W or X or Y or Z bar is actually equal to this is actually the second, the De Morgan's second theorem. This is the first De Morgan's theorem. So the second one, it says that the summation, the sum of the product, the complemented of the sum of the product is equal to the product of the complemented variables. So it becomes W bar and X bar and Y bar and Z bar. Clear? For example number 1.
Yes, sir.
Example number 2. How do you do this? Okay.
Macam tu lah, sir.
Okay, this one. First, you use the which rule? First one, you use the
The Morgan first theorem.
first theorem. So you get
Lepas tu
A.
second. Oh, yang tu ke, sir? D tu je, yang dekat darat D tu jadikan first theorem. Plus D bar.
Betul? Betul.
Lepas tu kita
First theorem. Then after that, this
second
one,
theorem. A, B,
you use
C.
the second theorem. So this one becomes A bar, B bar, C bar, plus D bar. Betul? Betul?
Yes.
Betul je.
This masuk situ. Here. So the second one, you get this. So this, you use which theorem? First, you use this becomes this is actually you use the
Second.
second.
Second
Second
theorem.
theorem. Okay. Then after that, this one goes to here, you use the
First.
first theorem. This also you use the first theorem. Okay. So this you use the first theorem. C. So you use the second theorem. You use the second theorem, then you use the first theorem. Okay, clear?
Clear, sir.
Okay, very easy. If you understand, very easy. Okay. Simplification using Boolean algebra. So I'm going to, I think we have a few more slides to go. I think about 2 slides. So now, simplification using Boolean algebra. So this is the process. A simplified Boolean expression uses the fewest gates possible to implement a given expression. So the purpose of us using the simplification is that in order for us to use as fewer gates as possible to implement the function. For example, using the Boolean algebra technique, we can simplify this expression. Let's say you have AB plus A or B plus C plus B or B and B plus C. So A or B plus A or A and B or C plus B and B or C. So the first one, here you use the distributive law for this. You distribute. So it becomes this part. So basically it becomes this. This. Actually, this part is this. Okay. Then this part becomes this when you use distributive law. Okay. Clear?
Clear, sir.
So you get,
Yes, sir.
then you use rule 7. Rule 7 here. It says that anything and itself becomes what? Becomes
Itself.
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 Yeah.
Yes,
Rule number 7. Yeah, rule number 7. A and A is A.
A.
Okay. So this usually becomes itself. So this B, BB becomes B. Rule number 7. So you reduce from this equation, you reduce to this.
B.
Now from here, basically that this part is AB or AB becomes A or A becomes what? A, right?
A.
So AB
Yes.
or AB becomes AB.
AB.
So here this part becomes this using rule number 5. So now we reduce further to this. You see, from here now becomes here basically 5 terms. From 5 terms, reduce again, because what happened is that for this part, instead of 1 gate, now you don't have any gates, just input. So now from here, you have 5 terms. Now you reduce into 4 terms. A plus AC plus B plus BC. So you reduce further. Then here, B plus BC is basically B1 plus C. Right? So this is actually equal to B dot 1, which is equal to
B.
P. So this becomes that. So now from 4 terms, you reduce to 3 terms. You use rule number 10. Then from here, okay, you can reduce further by rule number 10. What did we do? So basically that here
Number 10.
we move here, and here we move here. Okay, so that we get this. So
Yes.
what is this? This is actually
B.
A
Plus
plus 1 B.
B
So becomes
is
B dot 1.
B.
so B. So this is actually there. Okay, so now we have 2 terms.
Oh.
So therefore, can we reduce this further?
No, sir.
No.
No.
So this is actually the simplest. This is the simplest expression that you can have. So therefore, the answer is this. So now, what you have is basically, you have B. This is B.
AC.
A.
C.
And
D gate. N gate.
So that is the X.
Output.
So you come up with only 2 gates. For
Gate.
this one, you have 1 gate, 2 gates, 3 gates, 4 gates,
5.
5 gates,
Become 3 gates.
7 gates.
Become 2 gates.
So basically it's 7 gates.
7 gig.
From 7, we reduce to
6.
2 gates.
2. From 7 to 2. Because this is one gate.
Oh.
This one is another. This one is AND gate. This one is OR gate. This is an AND gate. So basically 3. This one is OR gate 4 and AND gate 5. Then you have a OR gate, which is a 3-input OR gate. Okay.
Okay, sir.
So that is actually the steps in simplification of Boolean algebra. Basically, you use all those 12 basic rules plus 2 De Morgan's rule in order to do the simplification of the algebra. So any question? So this one I'm going to do next week.
Okay,
So for
sir.
today,
Sir.
is done the lecture, and as your assignment, which maybe I give some marks, is here. How to work out from here, number 11 here, rule number 11 is from A plus AB to becomes A plus B by using this rules number 1 until 10, and for 12, A plus B and A plus C to becomes A plus B and C using the rules of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay,
Okay, sir.
submit to me by tomorrow or Monday.
More, sir.
Monday.
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 Okay,
Yay. Thank you, sir.
submit to me by Monday. Okay.
Okay, sir.
Okay,
So,
sir.
je kan,
any
sir?
questions so far?
Baik sir, baik
Any
sir.
question?
Faham sir.
Ha?
Faham,
Kalau
faham.
exam keluar tak basic rule ni?
Semua faham?
I mean,
Faham sir, faham.
Sambung
Exam?
3 jam lagi.
Exam ni
Sir,
banyak
kalau
ni. Exam memang benda ni keluar.
tak rasa
Oh.
table tu. I mean kalau face to face punya exam. Keluar tak dia punya table ni sir provide tak?
No,
Oh you.
we don't provide all this.
Kena
Face to
hafal
face, we don't provide.
Oh.
We don't for this for electronics. Last cohort, they don't have any formula given.
You.
No formula given.
Baik sir, baik sir.
Okay.
Nafas sendiri ya, sir.
Okay, sir.
Kena hafal sendiri. Okay.
Boleh, sir.
Sir.
Okay.
So any question so far?
Sir.
No. So
Sir.
everybody clear?
Sir.
Sir, ada orang panggil, sir.
Sir.
Dia ada panggil sir.
Yeah.
Apa ni? So maknanya kita ada 2 task lah, sir. Satu assignment 3 yang sir provide dekat dalam Moodle. Lagi satu dengan, yang sir baru bagi ni ke?
Yang ini separate.
Okay. Ke hantar
If this
sekali?
one separate,
Hantar sekali ke hantar asing?
hantar asing.
Alright.
Not in the same
Quiz lah,
apa
sir.
ni.
Yang ni
Put
quiz
in a
lah.
separate file. Put in a separate file.
Yang
Okay.
ni,
So this,
yang ni extra
so
mark,
this
extra
one you
mark.
put as quiz.
Extra mark sir.
You put as quiz.
Dua tu sir.
Ha?
11
Ha?
dan 12.
11 dan 12.
11 dan 12, je, thank.
So the question is that is the derive or proof that A plus AB is equal to A plus B by using the other rules, the basic rules. 11 and 12. Right? So maybe what I'll do is that I just write on the piece of on the document the exact question, and I will send to you.
Baik
Okay.
sir, baik sir.
Okay.
Okay sir.
So if there is no question, no other clarification, then thank you for your attendance.
Attendance, sir.
Yes.
Syarizuan jangan lupa keluar.
Baik, baik, baik.
So
Terima kasih satu.
okay. So basically that how many that we have? 20. Siapa yang mana 19 lah. 19, siapa lagi yang attend? Hafizuddin, Amarina, okay. Ayuni tak tanda lagi. And Dayana dah ada ke belum?
Saya
Dayana
datang
belum tanda
lah.
lagi.
Saya Ayuni ada, sir.
Jaga dah ada. Muhammad Ahmad.
Sir, Syareza,
ada.
Syareza, sir.
Mau ada sir.
Raja EJ ada?
Hey, sir, yes. I'm here.
You are here, okay. Cuma masuk lewat
Terima kasih,
Hafiz.
Yes.
Muhammad Hafiz, bukan Ahmad Hafizuddin.
Mak
Tak ada.
sir.
Hafiz ada tak?
Tadi bukan ada ke? Tadi ada sir.
Ada, sir.
Jaga Syakira ada?
Sir.
Ada, sir.
Mana? Tak ada nampak nama-nama.
Tadi mana?
Sekejap, saya check.
Sir, saya hadir tau, sir. Saya hadir. Sir Ayuni tu.
Ayuni ada. Syakira.
Kau ni. Kejap
Syakira tak ada. Syami tak ada juga. Tidur. Syami
Syareza,
tidur.
Syareza.
Ya Masya.
Syareza memang ada.
Siap 3 jam lagi, sir kan?
Syah ada tidur Syah.
So, okay. So, I dah tanda semua yang ada, yang attend.
Baik, sir.
Tadi nama
Okay,
pun banyak. 20 maknanya 19. Mana patut 19 orang? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Tadi
12,
Hafiz ada,
13, 14, 15.
So tadi Hafiz tadi, sir.
Tadi Hafiz
Hafiz
ada,
ada,
sir.
Tadi Hafiz ada. Masa saya tanya soalan apa tadi dia jawab?
Muhammad Hafiz.
Okay. Ada tak? Okay.
Ada sir.
Dia punya connection
So yang tak ada 2 orang. Syakira and Syami. So okay. Thank you. So I'm going to stop the recording.
Okay, sir.
Thank you,
Yes,
sir.
Baik, sir.
Okay. I stop the recording.